what I've done so far is I said basically consciousness is fundamental. Everything is generated within consciousness, and that our virtual reality is a data stream being sent to us from a server within consciousness. We're a piece of consciousness. We're getting a data stream. We interpret that data stream, and how we interpret that data stream, that defines our reality. So what is your reality? What's in your reality? It's what you interpret that data stream to be is your reality. Now, your interpretation of that data stream isn't necessarily what was meant to be in that data stream. It's your interpretation. So you'll get data, but you have to interpret that data based on your knowledge, your ignorance, your fear, your whatever makes you, all your experience, your total experience base up to this time is what you use to interpret that data. And you do it with pattern matching. You see patterns of data and you say, oh, that pattern looks like a human being. Oh, that pattern looks like a dog. Or that pattern looks like my house. That pattern looks like my mother's house. So you have these patterns, part of your experience, and you take it and do that. Well, now when you get data, then you don't have doesn't match any of your patterns. It's outside of your experience. What you do is come up with the closest pattern you can, and that's what you think's there, even though that's not what was there at all. Or if you can't find anything even close, you maybe just don't even see it.
Right.
Look right at it and don't see it because there's no pattern for you to see it. Or you look at it and it's a this or that, but the closest thing you have is something different, but that's the closest and that's what you see it as. So that's how our reality is formed, which means everybody lives in their own personal reality. It's shared.
So we all live in a personal reality, but we definitely have this like shared.
Right, because we have shared experiences. This is a multiplayer game. Same with World of Warcraft. And when those guys plant that tree on the top of that hill, everybody now who looks at the top of that hill will see that same tree. All players will get that tree. So all the players in World of Warcraft say, hey, did you see the new tree on top of that hill? And they all say, yeah, I was just over there. I saw it. Everybody sees it now. And they all agree that there's a tree on top of that hill because it's there for all the players. Okay. So yes. So we agree on things. We agree that, we're sitting in a room and there's a table in front of us and so we all agree because that we're both getting that data stream because the virtual reality is sending us a consistent data stream because it's a multiplayer game.
Right.
That's the way that works, but it's still our interpretation. Now, if we both have a lot of similar experiences, we'll probably interpret a lot of things similarly as well. But if we have really different experiences, all right, you're a high-stepping executive in New York, and I lived my whole life in the Amazon jungle, and I've never seen a skyscraper or a TV set or anything like that. I know about the jungle. Now you set us both down someplace. We don't have similar experiences. And the things we see and what we make out of the reality that's now in front of both of us is totally different. I'll see things and notice things that you won't, and you'll see things and know things that I won't, because we just don't have the same base in which to interpret the reality from. So we each live in our own reality, but we share in the game. So it's really hard for people to wrap their mind around it. What people do is they intellectually get it and they say, okay, virtual reality, data stream, I get it and all like that. But as soon as they start thinking about it, that old materialistic thought process comes back. And now suddenly, okay, it's a virtual reality, but what's the one set of things that'll compute the whole thing? And why, well, you're talking about a material thing. That's the way that works. Material things are machines. This isn't a machine. This is a larger consciousness system that is conscious. It's aware. It's making a tool, so it's going to do it the best way it can. So I'm going to go back.
That was it, tool.
Yeah, I'm going to go back, not to the last thing that you mentioned, but the thing before that, which was people, players. How many players do we need in the game? And there's
let's just say in this PMR.
Right, in this game, this PMR. Now, this PMR, physical matter reality, is what we call the physical universe. Now, the physical universe has probably many trillions of suns. And out of those many trillions of suns, it probably has many billions of planets going around those suns that aren't too hot and aren't too cold, and everything doesn't cook or freeze. There's some place in the middle where life can exist. So just looking at the statistics, there's bound to be millions. We've gone from trillions to billions, to millions. There's bound to be millions of places that have about the same conditions we do.
Right.
About the same conditions that we know life can exist in those conditions. And if it just happened to get started here, then why wouldn't it just happen to get started other places? The right amino acids with a little spark of static electricity or something turned into a bacteria.
Mm-hmm.
Why not? Well, there's a thing called the Fermi Paradox. The Fermi Paradox was created by Enrico Fermi. He and a bunch of his co-workers at, I think Fermi was at the Chicago physics department. And they were sitting around at lunch and talking about ETs. So because they're physicists and math-based guys, they start doing the math and saying, well, look, we're in a part of the universe that's relatively young. I mean, we're kind of middle-aged part of the universe, right? There's an older part of the universe. It's about 1 billion years older or so than we are. And then there's newer parts of the universe, but we're somewhere in the middle. So given that life happens elsewhere like it happens here, in that older part of the universe that's 1 billion years ahead of us, it should have happened there 1 billion years ago or so. And if it happened there 1 billion years ago or so, we'd have to say if it happened like it did here, then they would be like 1 billion years ahead of us in their science and their technology and their ability to get, not like, a millennia ahead of us, like 1 billion years ahead of us. Now, okay, given that they're 1 billion years ahead of us, given that Einstein's speed limit on going through space cannot go past c, so given that they could travel half the speed of c, let's say they could do half the speed of c, and given that they filled up and met their filled up their living space and had to expand, you have animal studies like that, you have so many cockroaches and here's the food supply. How many cockroaches are you going to have as a function of time, until the food supply makes them start to decrease their numbers. And they did that same kind of math. They applied to human beings and put in the constants that modeled human beings and said, all right, given this, they probably overpopulate the area that they're in so many years and then have to move on, and the technology and da-da-da-da-da-da. And they decided that all of the calculations show that certainly, to a very high degree of probability, the people in the older part of the universe should have been through this part of the universe by now. And they not only should have been through here by now, but they should have inhabited every piece of space that was inhabitable should have been inhabited up to the point of right up to the point of its carrying capacity. Mm-hmm. So right now, a place like the moon, that's inhabitable if you have technology that's 1 billion years more advanced than ours, and so on.
Sure.
and it would
all the real estate.
Yeah. So would be Mars be inhabitable if you had 1 billion years head start in technology. So all those places should be at their carrying capacity. In other words, full already and moved on to new spaces. Right. So the Fermi paradoxes, where are they? They should be thick through here by now. Yeah. Actually, not only by now, but,
long time ago.
Tens of millions of years ago, they should have been thick through this space because they're 1 billion years ahead of us. And that's a long time. So where are they? And that's considered in philosophy a very strong paradox because all the calculations that come to it were all done very conservatively. They weren't stretching out to make a point. They were being very conservative. And they got to this answer, and the probability says they should be here. They should have been here a long time ago. And they ought to be here shoulder to shoulder, the carrying capacity of this part of the universe should all be inhabited. So where are they? Well, if you think about any system, and this is true of any complex system, there is a sweet point in a system where when you do a cost-benefit analysis, adding another member to the system has a cost.
Right.
You have to feed it. You have to, there's a cost to it. And there's a benefit to it, that another member can help cooperate and pull some of the load and so on. So you'll have this sweet spot to where more is better, more is better, more is better, more is better. Oh, here, it starts going the other way. More is not so much better. More is, in other words, it costs more to feed another being than it does that the being actually contributes to the whole. So let's say now we have on this Earth, we have close to 8 billion seats in this simulator.
Right.
8 billion seats. Now we add one more and make it 8 billion and 1 seats. How much does that one contribute to the overall entropy growth of the system? Not much. It's just a teeny little bit. How much does that system require in cost? They cost another data stream. Another data stream has to go out to another entity, and all the calculations of everything they look at and everything they see, and every time they interact with somebody else, and they get in an arm wrestling match with somebody, who's going to win, and all of that all has to be calculated and the pictures sent out. So from that baby's birth on, there's what we would say very high bandwidth data is required continuously, except when the thing's sleeping. And then there's some in dreams. So the cost is about the same as everybody's cost. So you're going to add one more to the cost, but what's the system get back in overall entropy reduction? A tiny little bit, because we're pretty slow here. We don't decrease our entropy very much. One being, a lot of beings are de-evolving, are not evolving very quickly. So we're slow producers as far as we're here to produce lower entropy. We're very marginally slow producers as beings. And we got one more now that's gonna suck up another data stream. Well, there's a high point to this curve, and then there's a curve where you don't need any more seats in the simulator. Your simulator is full. So I think that 8 billion players in this particular simulation. Now this simulation is called the physical universe. So that's the whole universe. All 50 trillion stars and their, millions of planets like ours, all of it. Just us are 8 billion seats. How many does the system need in this particular physical matter reality? Another 8 million, another 8 billion, another 8 billion. I mean, then you're going to, how many trillions of seats does it need? And is that effective for it as a system trying to evolve? And the answer is no. And then you say, of course, the guys who are just trapped in materialism, they say, yeah, but all those suns and planets and stuff just going to waste out there. And
not even there.
They're not there. They don't exist. You see, when that big telescope looks out there and you see whatever you see.
Yeah, it just gives you what you need.
There it is. You see that. You see whatever it is. And as soon as you look away, it's not being computed anymore.
Right.
You see? So now what is being computed? Dots of light. Well, dots of light are cheap.
Yeah.
When it comes to computation, dots of light are cheap. And you only need dots of light for the half the population that's in the day or in the night that can see them. And then if they're in cities, you don't need very many dots of light because they can't see the stars anyway. So, and of all the people that are at night, most of them are sleeping. And the ones that are walking around aren't necessarily looking up at the sky. So you see, dots of light are trivial to keep track of. Just a
Right.
bunch of little dots of light. So it's not a
Sure.
waste at all. It's not like all that universe out there just totally wasted and we're the only life right here on this little planet. Well, that's absurd. Well, it isn't. We may be all there is, because
Exactly.
8 billion plus, going up maybe 10 billion, 15 billion eventually, is probably enough seats out of this particular virtual reality. So there's a very high possibility, given Fermi's paradox, that we're it. And that rest of that universe, of course, doesn't exist. It's just a virtual reality. None of it exists. Only there is no virtual reality where characters run around. There is no World of Warcraft where elves and
Mind starts going there.
run around, you see? It just exists in the minds of the players. So here are the players, and they're on this one planet, and that's maybe the only game in town. Those players are enough. The system isn't going to say, well, but this universe could hold 1 trillion players. Let's
Yeah,
go
but
do
why?
it. Yeah. No, it's not gonna put out 1 trillion more data streams for almost no gain at all as far as system evolving. It just
Right.
yeah, it would scale. You could scale it like that, but now you're putting huge amounts of processing on on the system that aren't necessary. It doesn't have any return. So it's just like that doesn't really exist. And no, it's not a waste. None of that really exists anyway. The only thing that exists is what you interpret. You get data and you interpret it, and that is your reality. So at nighttime, when you look at the sky, the system has to send some little dots of light in your data stream. So when you look up there, you'll see them, and you'll see all the stars in the right place, just where they're supposed to be. And that's part of our reality now. So that's the answer to, does it really take that many of us? No, it really doesn't. And no, it's not a waste. And yes, this whole physical universe, we look at it. So we physicists, we measure it, we look at our telescopes, and the system will give us data stream to tell us what's out there and what it looks like and so on. And we plot it, but we know about how big it is and about how old it is.
Yes.
And we've got all this data going, but that's just us extrapolating from what we see. And what we see is just the data that they put in the data stream for us
That brings me to
see.
the questions I wanted to ask you, which is, you measure the speed of light through a telescope, so on and so forth. This would be like real simple. Is the universe as old as we imagine? So 13 going on 14 billion years. Or, like we're saying, it just looks that way because of the rules we have here. So maybe I'm answering my own question. If we look out into space, it's like, well, it looks like it's about 13 billion years old, but that's just a reflection of what this system has set up. It would be like, well, yeah, it would look like about 13 billion years old. Is it really 13 billion? Yeah.
Well, 13 billion is obviously a wag. That's a very rough number. When I asked that question, you wrote it in an email. Says, is it really 13 billion years old? And as soon as you did that, I got a flash, and it said 15. It's 15 billion years old.
Cool.
But you can't put a whole lot of stock in that. But anyway.
No, but you get those flashes sometimes, and you're like, oh yeah.
I get a flash. No, it's not 13. It's 15. But now here's the thing. Okay, what's a year? Now we measure time in years. Okay, a year has to do with our solar system going around things. So let's say, all right, that's the clock for the whole universe, even though we're just one tiny smidgen of the universe. So that's the clock for the whole universe. Now, given what we said earlier about when this universe started, it may not have been really a big bang. It may have been something else. The initial conditions were whatever they were to make the thing work, and so on. And the clock was probably going by millennia, every delta t for a while. And okay, so now how do you end up calling that years? Years, which is the time it takes the Earth to go around the sun once. It's a little hard to say. And I got this number 15 and said, yeah, around that 15. but it's not really well defined because this isn't a physical system, and it isn't that we can't do that kind of measurement. So what they see, though, when they look back and they look out with their telescopes and see all this stuff out there, and they see how the light has Doppler shifted, so they can tell how the frequency changed and the speed that it's going, because that's what the Doppler shift will tell you, and it gets redshifted. So anyway, so they can make these assertions, and that's because of the rule set that we've got.
Mm-hmm.
So the rule set says that this universe would be about so big and so old and so on, according to the rule set. Mm-hmm. All right. That's what they get. They say, yeah, roughly 13. Mm-hmm. I got told 15, but I don't know that either one of them are right. But it's probably something like that. Now, I don't think it's a hallucination, like we're just seeing, we look in this direction and we're looking at the backs of our heads from another place. I don't think it's anything like that. I think it's just the rule set. We have a rule set. Things move at certain speeds. Light moves at a certain speed. You have Doppler shifts. You have all of this kind of thing going on. And we've even seen some gravity waves where a big supernova goes up. And when that supernova goes up, we can actually get a little signal here in a gravitational field. It'll shift a little bit because that source is not there. Okay, it only shifts in the 15th decimal place or something, but it's there. So our idea of the structure of our universe and what's in it and the trillions of suns and all of that is roughly probably true, plus or minus 50%. I don't know. I mean, they're just kind of making guesses when they come up with those kind of numbers. It's not like, oh yes, 13,565, million 327 and whatever, 6 days, 4 hours and 3 minutes, 10 seconds. That's how old it is. I mean, they're just taking a wag at it, and 13 million is probably close.
Yeah.
And 13 billion, is probably close.
Yeah, I mean, this happens all the time in cosmology. You've got stars that are bigger than what they predicted, whatever that means. and then
means their prediction was wrong.
Yeah, I mean, right on. In fact, later I'll send you a paper. Someone just published a paper in Quantum Foundations that's pretty neat. That's about something like maybe redshift, some sort of no, it was about dark matter and dark energy being a mirage based on, of course, like a misinterpretation, but someone just put something out there that I thought maybe you might be into. In a small way. It's superficial. It's kind of superficial. This is kind of like a side tangent, but I just thought I'd bring it up because it's like when we see a black hole, are we just seeing like a breakdown in the setup, or they're just a logical consequence of...
No, they're just a logical consequence of the rule set.
Mm-hmm.
I think they're just a logical consequence. So we look out and we see a black hole. Yeah, they're there, and they actually make sense because that's that big gravity pull that makes the galaxy spin, pinwheel spin around. If it didn't have that hole pulling it, it wouldn't be spinning like that. So, it's just a part of the rule set. So what the system shows us in our data stream, this is what a rendering engine does. It shows us things that are compatible with the rule set. It won't show us anything else because the rule set, this whole universe was created by the rules, these rules. Now, we only inhabit this one little planet and this one little part of it, and that's enough for what the system wants to do. But still, the whole thing has to abide by that rule set. This is a simulation. So that's
right. Like, look out there, it's got to look like this because these are the rules.
Yeah, these are the rules. So, yes, and they look out there and they say 13 billion years, and that's probably right. It's not right, like I say, plus or minus 50% or something, but it's probably sort of right. The best guess that we can come up with, given the assumptions that we have to make to do things like that. And yes, we are so much believers in materialism that, yes, you'll get things like dark matter.
Right. Sure.
and things like that. It's because when they do the math, they're wrong. It doesn't work out. Why
Mm.
should the universe still be not only expanding, but accelerating?
Accelerating. Right.
Oh, you got all this stuff, what? It's gravity. The gravity should pull it all back together. You should have the big smush. And it's not only not slowing down, which is what it should be doing, it's
Right.
speeding up, it's accelerating. How can that happen?
Mm.
Well, it just means that they don't understand the nature of reality. Of course, that
Mm.
can happen. This is a virtual reality.
Mm.
Anything can happen in the virtual reality. And
Mm.
if that suits the system's purpose, that's the way it is. I always use the thing that my son, when he was a teenager, he played Age of Empires. It's one of his favorite
Sure.
games. And in Age of Empires, there's a cheat. And you put that cheat code in, and you suddenly find yourself in a Mercedes Benz with a nuclear weapons launcher comes out of the trunk, and you can get rid of any of your enemies that you like very easily. And that
Mm.
was just a cheat that was put in there by the people who created, having a little fun at work, and they created that. So he got the cheat for it, and I watched him do it. And this is a game where you start out as cavemen, right? And you're
Right.
chipping rock, and then you go into the rock age, and then the iron age, and then you get you build yourself up to you can go outer space, and it's the evolution of civilization kind of things. And there's a bunch of players that are all trying to be the winner, the
Mm.
people that get to outer space first or whatever. So there's this cheat code. Well, that's like this. You can put anything in anybody's data stream if you're the larger consciousness system. So
Mm.
if a flying saucer that comes down and lands in your backyard, and all the little green people with pointy ears come out and come up to you and say they want a drink of water, they're thirsty, and you give them water, and they all get back in their flying saucer and fly away, and you go out and look and say, yeah, there's a burn mark, where the engine burned all your grass away, and there's
Yeah.
depressions
Or
where all the landing
radiation.
pads were, and you take pictures of them, and you record their voice, and you go through the whole thing. If the system wants to put that in your life, it's there. So
What about really
where do
odd
they come
stuff?
from, and what does it mean? It just
Yeah.
means the system put that in your data stream, is what it means. And it doesn't necessarily have to abide by our
Anything.
rule set or anything else. It's just there. Now, why would the system do that? Well, the
Okay.
system does that for one major reason, and that is to open people's minds up, so that you can see that reality is just bigger than what you learn in school. You have
What
bigger
about when it's
thoughts.
kind of freaky and unsettling? Like, the best example that comes to my mind, because as someone that's been curious about paranormal my entire life, but also familiar with your material, I've been able to see, like, well, it's probably just injecting these novel situations to get people moving. That's great. It's just the paranormal injects novelty into an otherwise static system. Great. Makes sense.
Right, right. A
So what
mind
about
opener,
what? Yeah, 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 yeah. Mind
a
opener.
mind
Exactly.
opener.
Well, what about when it's really kind of disconcerting for human beings, particularly, and this one of particular focus, like the mutilated animal phenomenon? Since we're going in this direction, why not?
Yeah. Well, I think a couple of things about that. One, just because somebody, again, sees a lot of mutilated animals, has pictures of those mutilated animals, and shows you those pictures, and their bodies are full of flies and other things, doesn't mean that there are any mutilated animals. This is a digital virtual reality. It just means that was put in somebody's data stream.
Okay.
Right? That was put in somebody's data stream. Now, why was that put in somebody's data stream, and did it really happen?
Mm,
Or did they just imagine that happened?
mm,
Now, what's the difference? You could think that happened,
mm,
even go out and see it and take pictures of it, and you could actually have the picture on your camera and you come
mm,
back, but that doesn't necessarily mean that anything really happened. It could be that no animals were hurt in this picture. It's
mm,
just you saw that data. So again, it's hard to get your mind out of the physical reality. We're so inured with it. We have that belief at the base that we see that, well, that's a physical thing and there's pictures. So there were dead animals that used to be alive. Not necessarily. Those animals are just pictures. Those animals are just just like we are. This body, there's no heart inside here. There's no lungs. I don't need oxygen. It's just a thing. You take a picture, okay, you'll see my body. Okay, now if you want to see a whole stack of bodies all in a real big pile, well, you can see that too. It's just a picture. There's not necessarily anybody actually died. You're just seeing, in your data stream, you get a whole pile of bodies in your picture, even gruesome stuff. Okay, it doesn't mean that anybody that was alive died. They may just be a pile of bodies in your data stream, you see. But you will jump to all kinds of conclusions because you believe in this being a materialist thing. So obviously, if there's bodies there, then they used to be alive. They used to be walking. They all have mothers and fathers and children here somewhere. And they were all somehow gotten into the spot and killed or whatever. And all of that must be true because you believe in materialism. So you create a backstory for it that suits a materialist viewpoint. You say that doesn't necessarily mean that it's like that. Now, people who see things that are terrible, for the most part, are fearful people. These are people who have a lot of fears. And I think a lot of what they see that turns out to be ugly is they're looking at a manifestation of their own fears. Now, that manifestation of their own fears may seem like it's out in the back 40, you know, in the corner of the fence over here by this tree. It may seem like that, but I think often it's just a manifestation of their own fears that these things happen. Now, you know, yes, people get picked up by flying saucers and then they get tortured or they get this or they get that. They get abducted and messed with and other things, but mostly that's their fears. I've encountered some of that too, but it's not necessarily that it's not part of the physical reality. It's not necessarily the people out there flying around that suck you up into their saucer and want to see how your liver works. You know, that's what that's the story we tell. That's the story that a materialist has to tell in order for it to make any sense. But it's not necessarily what happens. It's an interpretation of what happened. And what happens is that the data stream that you get has three potential sources. One of them is the larger conscious system. Another one is some other IUOC, some other consciousness, because all consciousnesses are netted. And the third one is your own consciousness. Now, there's no way for you to separate those. They don't come with flags. This one's mine, this one's somebody else's, this one's the LCS. You just get data. And there's no way to sort out where it comes from. Three potential sources. Now, how you interpret the data will often, will be because of the way you sort. So that could be data coming out of your own imagination. We'll call it imagination. Could be created out of your own consciousness that you're seeing, and it didn't actually ever happen anyplace. But the way you saw it was perfectly real, and you were there, and you took the pictures.
Now that you've mentioned it, yeah, sure. I've had an experience like that where I went out with a girlfriend at the time, and she was like, I want to go to this beach. And the beach happens, and I was like, we're going to find a really big dead thing when we get there. And it's the beach, so like the likelihood of that, of course, goes up because animals wash on shore. But what we didn't expect was it looked like it was a dead dog, like the skeleton of a dead dog. So it's like they very easily could have, like, if we're following the logic of what we're talking about seriously, it's like very easily could have been like, well, there you go. Sure. Here, have a dead dog. Have fun with your dead dog.
So see, you could have been creating that.
Sure.
And it was something out of a fear, or just a little, I don't know.
Kind of a
novelty. For whatever reason, that got up there. But you don't know it. You're getting a data stream. And you don't always know, oh, this is me, I'm doing this, because you're so engrossed in the happening of it that the source of it is never known to you. You don't know the source. You can never know the source.
Mm.
All you know is that you get data. Now, some of this data sounds like it probably came from me, okay, because I'm thinking about, what I'm going to have for dinner tonight at this party. So, all right, that's probably me. Why would the system send that? And some of it might be somebody else. So I get an old friend and I say, oh, they're probably thinking of me. So that's where that came from. And I get stuff like, how old's the universe? 15. That just seems to come from someplace else. Now is that coming from me? Probably didn't come from another IUOC. Could have come from me. Could have come from the larger conscious system. So that's why I say you have to be skeptical of everything. Sure. But we who are believers in materialism, we have to create a materialist story behind everything. Right. And often that's just not the case. And the system can put pictures in cameras.
Sure. Why not?
Yeah, why not? That camera is a virtual camera. That's not a camera. There is no camera.
That's a hard thing to keep in mind.
It's just a virtual camera. And it can make that virtual camera have anything on that film it wants to have on it. It's a virtual camera.
No, that makes sense because there's actually a wonderful art experiment where this guy was taking photos with a camera that had no light source. The lens was on, and he was able to use his intent to create funky, weird, like ectoplasmic pictures. Sure. It's like, there, use the film. Go ahead. There's a couple of artists who've done that.
Yeah, sure. So it's, that's a mind opener. The system lets us play those games because it helps open our mind. But some people scare themselves with it. But if you'll notice, all the people who tend to see horrible things and have these gruesome experiences, if you look at those people and talk with those people and listen to the things they talk about, you'll see that they're basically very fearful people. They're people who live in a negative space most of the time. So that's what they get. You see, they get that kind of thing. Now, sometimes what you get is just a fear test. Sometimes something will happen and it's just a fear test to see whether or not you're fearful or not, because growing up has to do with getting rid of fear. And if you're ready for the next step, then you'll pass that fear test. If you're not, well, then you'll need a little more time. And who knows what that may be. Almost anything could happen, and how you react to it will be a measure of how fearful you are. So yes, you have all sorts of people reporting all kinds of things, some happy and some not. But for the most part, it's a reflection of their own fear. And sometimes it may be just a fear test. You take somebody's, let's say, going out of body, and they're terrified because now they're out in this other space and they don't know, what if there's monsters live out there that eat people like me, and feel very vulnerable in this space. They don't know how to protect themselves in this space, and they don't understand it. There they are. And the first thing they're going to see is some big monster with two heads and blood dripping off its fangs. And, that's what they're going to see, because that will be a manifestation of their own fear. That's what they'll run into. And sometimes those dreams can happen here and they seem like they're us awake. And even there's evidence, to support that it was us awake. And how do you react to that? Does that crumble your life and you go around feeling like a victim the rest of your life? Or do you, suck it up and go on and say, well, okay, that happened. I don't understand it, but I'm not going to let it ruin the rest of my life. So let's just go on. Then that's good. That says you're maybe ready for the next step. So it's hard to say, but it's not that there's evil all over the place and we have to constantly fight with the evil demons and nasty.
Yeah, I doubt that. I think that's something that people just get in their minds, that they're like, oh, the reptiles, oh, the demons, oh, the New World Order, all these evil things. And I have to fight it from the safety of my computer. I have to spread the fear so everyone knows about the fear.
Yeah. They're just fearful people who get easily sucked into fear. So anything scary, they love it. They don't love it, but it frightens them, so they gravitate toward it.
I got it. I love a good ghost story, but it's just for the little like woo, like that's it. A little tickle. The I remembered what the other thing was is that because I've never heard you use this, which was tool, to think of the reality and like the data stream as well as our bodies as like the tool. This is the learning, because I'm no learning lab, of course, but I love learning tool. That's a little bit more immediate. I've never heard you use that phrase before. And I've heard your recent interviews about, AI and stuff, and being like, well, that's certainly accelerating the need to grow up quite quickly, isn't it?
Yeah.
Um, all I'm trying to do is put like my big toe in a little vocabulary for them to just sort of approach
Mhm.
it from a philosophical or slash cosmological angle, because there's some movers and shakers right now in the anthropic dialogue, Bostrom being one, and I was like, oh man, if you can convince Bostrom, you can probably do some good effort to get that model out
Mhm.
there. I also have an illustration that I made years ago of exactly what you describe, which is the 1010 and then the time thread showing up and
Mhm.
everything. Otherwise, yeah, the goal with this sort of little project I've got is just like, use the literature that's already out there, that's already kind of going in your direction, and then just try and bring your material into it, represent it meaningfully, and of course, I'll send it to you before I try and do something with it. But I was thinking this might be a good angle of attack.
You
Sure.
kind of latched onto Wheeler, which is, I think, very good. Wheeler, I think, is probably the best physicist, in the last, 100 years or something. I put him up at the very top of the pile. As far as he's almost contemporary, it was not that long that he's just died in the 2000s. He made it
Yeah,
into the 2000s, but
and he has experiments that can be done. He's not just flirting with the
yeah,
ether.
no, he was really one of the great physicists. Have you heard me talking about the speed of light that's not a constant?
Sure, I bumped into that also with Sheldrake. He had a great joke
Yeah,
about checking like, is the speed of light up or down today? And I think that I'm familiar with too.
yeah,
There's a
because
lot of your material.
it turns out that my model would predict that it would go up and down in about the eighth or ninth decimal place every once in a while. That should happen.
Yeah.
We should expect that to happen because the speed of light is actually the delta x over the delta t. Delta
Mm,
x is a pixel, a distance pixel in our simulation, and delta t is a time pixel in our
right.
simulation.
Yeah.
So if you take delta x divided by delta t, you get the speed of light. So that's why we say the speed of light's a constant, because it moves one pixel every delta t, and that's as
And,
fast as
and,
it can
and
go. And then
mhm,
that's why it's a constant, but then why it's not a constant is because a simulation doesn't always run at its maximum resolution, because
sure.
more resolution is just more crunching for the computer to do. So it doesn't
Mhm,
run at any higher resolution than it needs to. So
mhm.
what happens is the our resolution is delta t and delta x. That's the time resolution and the distance resolution, space resolution.
Yeah.
So we might want, as we see scientists start digging deeper into reality, the resolution needs to go up so that what we find now is small stuff. So the resolution has to change. So how do you
Mhm.
change the resolution and keep C a constant? Well, you can't exactly, because it's digital. So you have delta x over delta t. You can't just divide delta x by 2 and divide delta t by 2, because you'll end up with a point, digit, but you got pixels. You can't just make it any place you want. You can only get as close as you can get to the nearest pixel. So yes, you want delta x and delta t both to be half their size, which means our resolution now is higher resolution. We got smaller pixels. Then you can only do that by adjusting the two to stay to constant delta C as close as you can by shifting to the next pixel. If I shift to this pixel, oh, now it's too low. Oh, I shift to this other pixel, now it's too high. But the one in the middle, it's not just right either, but that's as close as I can get to it, you see? So you expect this down in the 8th, 9th, 10th decimal place. You should see that the C will every once in a while change because the system needs to upgrade the resolution to which it's calculating.
That's a fine paper right there. Like, I don't think anyone's written that. Now, you could probably write it in a few pages, right? I mean, in fact, has anyone, and sorry if this is amateur, because it is, but has anyone, or is it just obvious? Would it be just obvious to write, to say like, a way to understand C delta X over delta T? Would be publishing that, for example, be like, would like a physicist look at that and be like, well, duh, or like, would it be redundant?
What you could do to make it interesting is that Rupert said the times that it had shifted like 4 times or 5 times in the last 20 or 30 years or something. You could look at the times that it shifted and see if right after those shifts were times that we did something like built a new linear accelerator or a new hadron collider or something that the system was trying to upgrade the resolution because we were doing things that required more resolution. So that would be the thing for you to do, would be to take his numbers of when C changed a little bit and see what was going on, because it would have wanted to make the change not the day before, but sometime before that event or sometime after it knew that we were headed in that direction. So you hopefully will be able to relate it to things going on in this virtual reality, so that there's a correlation between those little C's. Not quite. Man, and you see whether it went forward or backward, got a little bigger, got a little smaller, just depends on where it happens to land on the pixels. There's nothing meaningful about whether it's a little smaller or a little bigger, because it's just those pixels. Because if you divide what that delta T is by 2, you'll get a number with maybe an infinite number of digits to be the exact half. Well, you can't have an exact half. You're going to have to come back up here to where it's just this much of it. And when you do that, there's going to be some error. You can't have 1,000 decimal places. Won't work, or 1,000,000 decimal places, or infinite decimal places when you divide by 2. You say, well, here's the ratio. I'd like to make them both about half size, but this is as close as I can get to keeping C a constant. Either one, I could shift either one a pixel one way or the other, and it's a little worse. These 2 pixels I've picked are my optimal. So it could shift C a little higher, a little lower, doesn't matter. It's just that's as close as you can get. But it's in that 8th or 9th decimal place. So what that tells you is where the resolution is. Now, the resolution doesn't have to be the same everywhere. If you were doing a very big simulation, you would be doing, and I talk about this in my book, if you're doing a big simulation, you're going to simulate, rockets at, probably a 1,000th of a second, delta T, because they move enough distance at a 1,000th of a second that it matters. Whereas if you have a man running through the bushes, you're not going to want to have to model him every 1,000th of a second, because you're just going to waste a lot of computer time, because in a 1,000th of a second, he doesn't do anything useful.
Oh, I remember, I think. I remember.
So you'd have a shorter model. So we have in this whole world and different places on it, we have different resolutions that the system will use because it's trying to be efficient. It's a good computer science guy. He doesn't want to just make everything at delta T over delta X. That's the maximum. That's the maximum resolution you can get. And I want to do everything at maximum resolution. It does a lot of stuff with a lot less. Well, how much less does it do it in? Well, what was that decimal place where it changed? that's our where our resolution is. If it changed in the 8th decimal place, then it means it was around in 8 decimal places is where it was calculating our smallest resolution. The delta x and delta t are the maximum resolution that you can get. That's the pixels. Those are the pixels.
Right.
So it's that's a lot smaller. You take delta x and delta t, if that's the Planck length and the Planck time, they're like 10 to the minus 40 something, 10 to the minus 36. They're really small. They're not 8th decimal place. They're more like 15th decimal place or something much further out. So you can see where the resolution has been and where it is now based on where those changes occur. And you might find that the first change that was made was at the 7th decimal place, and the next change that was made was in the 8th decimal place, and the last change was made in the 9th decimal place because the resolution kept going up. So there's some things like that, artifacts of that you could maybe dig out and see if you can relate it to what was going on in the world. Who's measuring the speed of light where? Because all parts of the world don't necessarily run at the same resolution. If you're in a world that all you do is sit on a stump and watch your sheep eat grass, and that's kind of the way life is in that part of the world, then you don't need resolution, to even 5 decimal places to describe that kind of a world. 2 or 3 decimal places is probably good enough for that. So why waste bits and by giving it more resolution than it really needs? So anyway, you might find something there if you did that. But I said that right after I saw Rupert's thing. I did a little reply to Rupert, and I thought about it for just a little bit, and I said, oh, that's why that speed of light changes, of course. And that's why it changes out in that decimal place, because it's the systems had to up the resolution a little bit because we starting to dig deeper and deeper into the matrix, if you will, and we need to find something there that we can measure. So it's got to do that, and it's not going to spend gobs of time doing everything at the Planck length and Planck time. They're too small. That's stupid to do that. We can't even see anything that small. Why would we compute our reality at that level of resolution? That wouldn't make any sense. So I didn't know whether you were aware of that little thing or not, but if you want to go publish that and find something and make it up, have at it. That's not my thing to do. My thing is just to come up with good ideas that explain things, and I let other people go off and do something with it.
I love that. I think this may have been it, or it might have been related to the thing that we were trying to remember, but it was I wrote a paper a couple of years ago, about 2015. It was the most popular paper on the IEET, the Institute for Ethics and Emerging Technologies. It was the first essay I wrote that really got me a lot of attention. And what it was called Why It Matters That You Realize You're in a Computer Simulation. And the argument I put in that ended up in my collection of essays. And that was, people were arguing online and publishing that, like, well, if we live in a simulation, we have to play dumb, because if too many of us figure it out, or if that message gets out, then the simulation will be useless and it'll self-destruct and will all be deleted. It'll be like this cosmos-wide apocalypse. And so my paper was against that and saying that's ridiculous, because if you have your little sims in a simulated universe and you give them, let's just say, unlimited time to develop their intellect, okay, then eventually they're going to bump into that they're in a simulated environment, right? So that was just a logical consequence of that whole situation there. I'm thinking, my question is that, so we have this rather seamless simulation, rather seamless. You have to really interrogate it with lasers if you really want to break through and be like, aha, oh, it's an information system. Going back to our original thing, like chat rooms. Okay, we got that layer. I know we got communication protocols, first layer. Then you get, okay, your simulated environment. That's another layer. And then below that, you get like, okay, embodied in some kind of way. And you got that layer. All right. So, and here is this system trying to lower its own entropy, basically quite novelly, like breaking itself up into pieces and having them interact. Like, okay, that's going to be my strategy here for lowering my own systemic entropy. All right. A couple of things. One, I don't think it's, or my hunch, my intuition is that it's not in horrific crisis. If it's gotten this far and is able to do this, it's probably doing pretty good in generally speaking.
Well, better than that, it wants you to understand that it's a virtual reality.
That's where we're going.
It wants you to understand it's a virtual reality because the whole point is it evolves because we evolve because we're a part of it. So it wants us to evolve and find out that love is the answer, that cooperation and caring is what it's all about, and that it's all about reducing entropy in a social system. See, it's entropy within a social system. And that's what IUOCs make. They make a social system. They're interactive. And within a social system, you reduce entropy by cooperation and caring and supporting each other. So it's just that simple. And if you find out that that's the case, well, now you know that that's your mission. That's what you're here for, is to grow up and lower your entropy and become caring of other people. Well, that's a good thing to know. The system isn't going to try to hide that from you. It wants you to figure that out. You're much more likely to evolve if you know what the game is and and how to play it. If you're just clueless, wandering around in the playing field like most people, it's kind of hard to contribute much to the game. But once people go, oh, I get it. We're pieces of consciousness. We're here to, to grow up and not be so fearful and self-centered. That's the whole reason I'm here. Well, then that helps them grow up. They finally get a sense of why they're here. So the system wants you to get there, but you have to get there on your own.
On steam, yeah.
You have to get there because it doesn't help you grow up for you to act. Let's say everybody knows, all right, this is a social system, and the way you grow up is to be nice. So everybody decides they're going to act nice now. So you got lots and lots of people who are really just the same ugly people they were before, but they're all acting nice. Well, that's good. It's more civilizing. We get along. There's going to be less murders and arguments going on because everybody's acting nice, but nobody's growing up. It gets in the way of their growing up because they think they already are grown. Is that behavior they think is the measure of being grown up. Behavior's not it. Its intent is the measure of growing up. And if you think that behavior's it, that'll actually stop you from growing up because you'll say, well, I'm already done. I'm nice, I'm cooperative, and I do all these things, so I'm done. And you don't try anymore. So it doesn't want people to intellectually know this as much as it wants them to understand it deeply, so that they have to be kind, not act kind, in which case you're on a path of discovery. And as you grow up and learn and get more and more grown and less fear, then one day you get oh, I know how it works. Okay, yeah, that's my mission. Well, you'll get there someday. And when you do, then you decrease your entropy and you grow. But just to go around and telling people, say, okay, here's the cheat sheet. What you need to do to get by is to act really nice to everybody, and that'll help. Well, what that does is basically end the education. So that's a worse case. It's better to have somebody who's uneducated and then realizes it than it is for everybody to think that they're done and doing everything that they need to do, because then they're never even looking for anything else. They've arrived. So It's not a thing to learn intellectually. It's a thing to learn at a deeper level. And the only way that works is to let people get there as they get there. As they're able to change themselves, then they get there. Before they're able to change themselves, they're stuck in their intellect. In no sense telling them something they can't use. So it's not that the system doesn't want people to know it's a virtual reality. It'd love for everybody to figure out this is a virtual reality, and it loves the answer. But they have to get there on their own so that they actually do understand it and become love, not just mimic it and act the way they think they're supposed to act, because that will stop their progress. So the system wants you to figure it out, and it leaves clues and does all kinds of things to try to open your mind to figure it out. It's aliens opens their mind a little bit in our culture, just to get them out of the rut that most people are in their thinking and what's possible. So the system does all sorts of things for people, gives them all kinds of experiences. Most people who are on this path of growth had a paranormal experience sometime in their life that showed them that life was a lot more interesting than they thought. There's a lot more to it. It's not just this mechanical machine that we somehow work our way through. And that turned them into seekers. So they go out on the internet and they start seeking and looking and coming, and they end up in New Age, or they buy crystals, or they read My Big Toe, or who knows what they do. Yeah, go searching for Bigfoot, or they do something.
Coast to Coast AM.
But it gets them started, at least thinking out of the box, which makes it more likely that they'll think another step out of the box. And you got to get out of the box first. So kicking people out of the box with a crop circle or a paranormal event that happens in their life, that's the thing. Kick them out of the box. Get their mind open to possibilities other than just the mundane rut that they're in with their thinking. And that will help stir the pot, help people think and grow. So the system does a lot of that. It's not trying to keep it a secret. It's it's shaking the cage all the time, saying, "Hey, folks, wake up! Look at this. How do you explain this?" It finds people who are ready and gives them experiences to basically blast them out of their comfort zone and then turn them into seekers. That's kind of the way the system works.
What would be the end game, if we can imagine one, on for us in this PMR? Because if we take what we're agreeing here is like evolution as an entropy reduction situation here, in a social system on Earth, all right, and it just plays out on Earth, let's say to maximum efficiency, right? Let's just say everyone gets it like that, and then just imagine it like in a century time frame, a 500-year time frame, a 1,000-year time frame, so on and so forth, and so on and so forth.
Okay, I'll answer that.
Yeah, you can see where I'm going.
Yeah, sure. Okay. Well, what would happen is several things. One, entropy reduction requires energy input. And that's true in our world, physical world. That's true everywhere. So just entropy is about a system, and you have to put energy in, to get an entropy reduction. You have to do something. You have to order things differently, or at least create the order. But that takes effort. Creating order isn't just something that just happens. You create order. It's an input to the system. So if you evolve and you have almost all your fear gone, your entropy is very low, you have to continue to work on that. You have to continually be aware of that. Otherwise, you'll start to de-evolve. If you just say, okay, I'm done, I quit, I'm perfect, now I'll just quit. Okay, now what are you going to do? Find that cloud and find a harp and go sit on it and play a tune for the rest of your life? What are you going to do then? Well, if you quit, working on it, you'll start to backslide and your ego will start to grow. And pretty soon you're not only done, but you're better than most of the people who are still working on it. And then you'll start feeling proud of yourself and it'll all just go downhill. So what you do is you keep engaged. So this is not the only reality frame. There are other reality frames, most of which are behind us as far as their evolution goes.
Is that right?
Yeah, mostly. And you would start incarnating there to be helpful, to be a good example, to be a teacher. You'd start going to wherever you were needed. You'd be coming back here because there's always new coming in. And the new doesn't come in at the top. The new comes in basically in an average. Comes in at around an average spot. It doesn't come in low or high. It comes in around an average, so it blends. So it comes in at about an average space. So there's always new coming in. There's always people making poor choices. There's going to be people making poor choices. There's always going to be people who will need help and support and encouragement, no matter where they are. So, and there's lots of other reality frames. I shouldn't say lots, but there's several other reality frames like this one that aren't as, some I've been to are much, much worse than this one. Others are maybe about the way we were, I don't know, maybe 400 or 500 years ago, 600 years ago. They've gotten about that far. And, you know, you go back 500 or 600 years and we were a lot worse than we are now. You know, that's, you know, life was really cheap, right?
Yeah.
You had the warlord on the top and, you know, the peasant on the bottom, and the warlord could do whatever he damn well pleased because he was the law. He made the law, and he could take whatever advantage he wanted to take. So that's where we were up to about 500 years ago. We started doing a little better than warlords being in charge. And we're still fighting those battles. We still have a lot of people want to go back to the warlord model, would rather be in a totalitarian government or a fascist government for some strange reason. So that's still alive in us, but at least we're a lot further than we were 500 years ago. So I've seen some that are that way and some that are much worse, some that are in between. I've been one or two places where things were maybe better, but really not much.
Yeah.
Not that much, and it wasn't as big. You know, the bigger the system, the longer it takes to grow up. You know, this is a big system. You know, 8 billion people is a pretty big social system to become love. That's you know, that takes a while. But I think in general, we're doing pretty good. So you would still be involved in being helpful and being useful and doing what you could wherever it was needed. That would be, you know, that'd be what you do. So you're never done. You'd never get to the point that you say, okay, I'm past, I don't have anything to do now, because not having anything to do now is not productive. If you don't have anything to do, if you don't have any ways to help and any ways to share and any ways to help improve somebody else's life, you'll start backsliding. Your ego will start to grow. You will lose some of what you've already got because you keep it that way by your exercising that low entropy. You know, low entropy is not an idea. It's something that you are. And if you stop doing it, then you aren't it anymore. You know, you have to keep expressing that low entropy, and that would be where we would get to. Now that seems to me to be a long way off. You know, we got a long way to go. But if we did get to that point, that would be good. We could maybe find other things to do. Maybe our larger conscious system isn't the only larger consciousness system out there. There may be other LCSs that are doing other virtual realities, other places, who knows? And maybe they need some help. You know, I don't know exactly where it would go, but I think there would always be something to do. There's always some way that you can help the system, because there's a lot, like where we are now, there's about as much backsliding as there is going forward. You know, it's one step forward, two steps back, as a lot of it, and then we maybe get 3 steps forward and only 2 steps back, and that's good. But it's a slow process. And there's
Yeah.
always new coming in as the population increases. But
Mm.
anyhow, so there is no, I'm done. It's
Oh,
just,
and yeah,
it's just
I wasn't so much.
where can I help most?
Gotcha. Yeah, I've kind of already given up on the concept of done. I was thinking more about, like, um, maybe the system itself doesn't even know what its teleological end game is. Maybe it just knows that I need to survive, and this is the strategy I've come up with to survive.
I think that's probably possible. Now, who knows? There could be other LCSs out there. And, in my book, I get a little silly with that because I want people to realize it's nothing but wild speculation. Remember, I talk about an Almosaurus, which would be
Oh, yeah, right. I remember
a
that.
whole creature made up of Aum cells, and each one of those little cells in this Almosaurus is a whole larger consciousness system.
Sure.
So so it's just wild conjecture, but who knows what's there. So I think there's
Yeah.
enough though to keep us busy for as
Yeah.
long as we can imagine, and then longer.
Yeah, that's a place that you probably can't, or that I don't know if anyone could go to. And I've heard you say it over and over again, and it's almost like, sorry you get asked it, but you're going to get asked it anyway, which is just the ultimate alpha there. The something showing up. It's so, one of the, and this is gonna sound a little wild, I suppose, but I'm sure people have told you, like, you know, in the past, I'm sure people have mentioned to you, like, boy, my big toe really is something. I've had psychedelic trips, and wow, when you close your eyes, you really get the feeling of an entire universal computational process going on there. It makes a lot of sense. And then when you kind of dive into certain questions and things, certain interesting answers show up. And the one that keeps on bumping up to is that, why is, you don't even need psychedelics for that question, but like, why is there something rather than nothing in the blip? And I guess you're just going to go to bacterium, huh? It's just that, like, you can't know. There is something here, but like, where did it come from and why? Where did it come from
Yeah,
and why? I mean, you got your
yeah,
cells. Your cells make sense, where you got like one state A and state B. Give state A and state B enough time,
yeah.
maybe.
This is what you get exactly. But you can't get outside of the larger conscious system because that's what you are. That's
Mm,
what defines you. You're a piece of the larger consciousness system. So to get beyond that
can't
is you can't do that. That's just logically impossible. You
Can't be
know,
done. Yeah.
yeah, you can't do that. Now, if the larger conscious system was, you know, a part of other systems, then yes, you could get through that system to other systems and things. But there's no, there's really no sense of that. And of course, there can be nested systems. You can have a virtual reality that spawns a virtual reality that spawns a virtual reality, but that's bad computer science. If you come to do that, it doesn't work because it makes the ones in that series vulnerable and creates huge overhead for
Oh, sure.
the processor. So if I got five virtual realities, one inside the other, like a big Venn diagram, and one inside the other, inside the under, well, if something goes wrong out on the outer loop, everybody crashes,
Right. That makes
and all the data going into the one that the fifth one in the middle, all the data has to flow through the first one and through the second one and through the third one. All that data has to be passed through all of those before it gets to the fifth one. So having them one inside another, yes, that's it's possible, but it doesn't make good sense. It's not good computer science. It creates a fragile system. Any break
Yeah.
anywhere kills everything downstream of it. It
Right.
creates an overload of overhead on the first systems that have to pass through to the next one, have to pass through to the next one. And it's just not a good thing to do, which is it's kind of the same argument that the many worlds the same problem the many worlds people would run into. It's not that many worlds is logically impossible. It's just that it's irrational as far as, it's impractical. Let's put it that way. It doesn't make any sense, you can't have infinite numbers of reality frames,
No, I mean,
It's
that's
just,
pointless.
it just doesn't go anywhere.
Right.
It's a huge resources in order to accomplish something that can be done very economically.
Mm.
The MBT system is very economic. It's all done in probability. Yes, there's all the possibilities out there, just like you
Sure.
get in the many worlds is to cover all the possibilities, but they have to cover them in physical space. You see,
Right.
in MBT, I cover all the possibilities too, but it's all in math space. It's a lot easier. It doesn't take up any room, It's just computation. So yes, there are all these possibilities and you get to choose. And as you choose, the probabilities change because you are consciousness in a game with a larger consciousness system. So you're a participant in that game. But you also can modify the future probability. So you can make things more likely or less likely to happen in the future. So that's a way that you participate in the possibilities. You modify the probability of the possibilities. You don't really change the possibilities so much as you modify the probabilities of the possibilities. So all
Right.
those things that happen from a random draw from a probability distribution of the possibilities. Well, if that probability distribution changes, then what's likely to come out of that random draw changes. So you're a participant in the fact that you are affecting future probabilities. You're affecting the probabilities that that random draw. That's the wave function collapses to a physical particle nonsense.
Right.
Metaphor.
Yeah.
But you have some impact on that. You're not only a player in the game, but you're an active player in the game that can modify the way the game turns. You have some input to the game. And that also is, makes you a participant, you're not just a player getting a data stream. You're more than that. You're a piece of the whole thing. That way we can look at ourselves and look at our culture and look at the world and say that this world represents us. It's a sum total of all of our choices. For the last 5,000 years, you take all the people who've been here and all the choices they made, and here we are. We're the sum total of all the choices that have been made. Had we made better choices, we'd be different now. Wouldn't be like this. So we get to participate in the future probability. We can raise and lower the probabilities from that random draw function that is what says what happens next. So that's really makes us an active participant, not just a passive participant in a game, but an active participant. And as we understand the game better, well, then we'll make better choices. And as we make better choices, those probabilities will move toward more positive outcomes rather than more negative outcomes, which will probably help us make even better choices. So you see, it's got a feedback system that's supposedly will help itself grow up. So we're not just, here you are, throw you in this system and see what you do. It's not like, a little boy putting two big spiders in a jar and seeing what happens. There's a system here going on that's supposed to, with its feedback, generate a progress. So it's not just random stuff happens. It's our choices. As we make better choices, we make it easier to make better choices later. And then that's easier than better choices later. The more you know, the easier it is to know more. It's a cumulative kind of thing. And as you make better choices, it makes it easier for the people around you to make better choices because you become a more positive influence on them. And as they make better choices, it makes it easier for people around them to make better choices. You see, so it's got this built-in success function, if you will, and that's part of why we're here. So it's not that this is this virtual reality and we're thrown into it with a bunch of hapless players to, like a kid throwing two big spiders in a jar, and seeing what happens. It's not like that at all. It's a system that's very positive, wants us to succeed, sets us up in a schoolhouse to succeed, bias is in our favor to succeed, but we've got to do it. We've got to learn the lesson. We have to change who we are. We've got to make that difference. And as we do, the whole system will evolve. So it's not as cold and sterile as it sounds like. Oh, this is just a virtual reality game, and we've been thrown in it as players, and the whole thing. The larger conscious system must be evil, because otherwise, why would we have so much dysfunction here? And we have dysfunction here because we make a lot of poor choices. It's us. All that evil comes up out of our bad choices. We got to grow up. Yeah.
I like that idea of success function. That's actually a good point. I've noticed that, in my family, when someone starts making some really positive changes, it is accumulative and infectious.
Yes, it is. And unfortunately, it works that way negative too. If somebody starts making really negative changes, that's also infectious. It kind of drags everybody down with it. That's because you modify future probability with intents. And if you have a whole lot of people with positive intents, well, it just keeps getting more positive. It's the function, what do we call that in electrical engineer? That's a positive feedback. Positive feedback means whatever's going on, the feedback helps it go on more. And as it goes on more, the feedback gets better, gets bigger, and makes it go on even more, and it just keeps, it's winding its way towards success. It's a positive feedback, whereas negative feedback is a feedback that slows it down. If you got something that's going on, the negative feedback says, slow down, a little less of that, a little less of that. So in Double E, it's basically a system of beings that have to interact socially, but it's driven with this positive feedback that it's slow, we're slow, but it's positive, and we just keep getting better. Look back in history, like I said, 500 years ago, 1,000 years ago, man, life was really, really cheap. If the boss man wanted to do a little sword practice, he could get a couple of peasants together and practice skewering them, just because it made him chuckle that day, and that was fine. That was just life, the way it was, life and death. And we don't have that kind of thing now. Sure, we have a lot of despicable people still running around in the world, but it's not as bad as it was. We're getting there. That success function is chugging along. It's a positive feedback system in the world. The more you grow up, the easier it is to grow up more. And that the more you de-evolve, the easier it is to de-evolve more. It works both ways. But you have to keep it going, get better. If you go backwards, then you have to just keep chugging until you go forwards again.
I always love it when you wrap up with that real positive. Remember, it's not going bad. It's actually going pretty good.
It is. It is. I and MBT Events hope you liked this video. We will continue to post videos for free on my YouTube channel, but please understand, these videos are expensive to produce. They represent many thousands of hours of production and editing, as well as all the necessary audiovisual equipment, computers, and software. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.